factor. Let's factor this down. So we have our A, our B, and our C. Make our box. So when it says equivalent expression, that's factoring. So our A term will always go top left, and our C goes bottom right corner. Make our X. On the top of the X, take 3 times -2, which is -6, and B is -5. So don't say it out loud. Just give yourself a moment to think about it. What are 2 numbers that would multiply and give you -6, but add to be -5? Any ideas? Any guesses? What are some numbers that can multiply to give you 6? 2 and 3. And what else? 6 and 1. Now, if we use the 6 and the 1 and we make the 6 negative, -6 times 1 does multiply to give you -6. -6 plus 1 does equal -5. So that's my other 2 numbers that will go in the other 2 boxes. Danielle, can you close the door for me? Thank you so much. All right, so let's go ahead and break down our boxes. So a 3x squared is 3xx. A 6x is a 3 times 2 times x. A 1x is just a 1 and an x. And a 2 is a 2 and a 1. So let's take out our GCF. Like, what's in both boxes? So when I look at these 2, they both have a 3 and an x that can come out. And both of these boxes have a 1. So I'm taking out a 3x and a positive 1. Now, what's left that I didn't highlight? The only thing left in these 2 boxes is a what? Is a x and a 2. So we're going to take out an x and a 2, except the 2 has to be negative because it's touching a -6. So your equivalent expression would be 3x plus 1 and x minus 2. Any questions so far? So let's go to our notes. So this chapter is all about exponential functions. Exponential functions. So what is an exponential function? An exponential function is simply a function that has a changing exponent. It's a function that has a changing exponent. That's all it means. So exponential has a changing exponent. So we're going to skip over example 1 and go right to our transformations. So this should look familiar at the bottom of page 2, A, H, and K. So I'm going to give you a moment to copy this down. And this was on our test yesterday, except we were talking about square root functions. But just realize that no matter what, it doesn't matter what kind of function it is, A, H, and K will never change. A is going to be the number in front of the base. It's going to reflect it when it's negative, stretch it when it's bigger than 1, compress it when it's between 0 and 1. H Now h is in the exponent. So your h value is in your exponent. And you still flip the sign. So you flip the sign. So if the exponent has a +2 or a plus, that means that the h value is negative. If the exponent has a minus, that means the h value is positive. K is in the back. It moves the graph up and down. And we'll talk more about this today and tomorrow, but just know that if the base of the fraction is bigger than 1, that means it's going to grow. If it's between 0 and 1, that means it will decay. Today, we're only going to do exponential growth. So let's go to the next page and let's practice identifying what our A, H, and K and our B values are. And we're going to use our matching more than one. There will be more than one option. So let's go ahead and dissect this first one. So in this first one, A is 5. And the B value, so this is A, your B value is 4 in that equation. So because A is 5, is that going to make it stretch or compress? What does it do when A is bigger than 1? Does it stretch it or does it compress it? Stretch it. So what option says stretch? Looking over here, which one of these say stretch? Which letter? B. And because the base is bigger than 4, it's going to grow. So my answers for the first one are B and H. Those are my two transformations. All right, let's look at the second one here. This is your A value. So A is 4. And let's go. When A is 4, what is that going to make our graph do? We already said that when A is bigger than 1, it's going to stretch it. So we're going to use letter B again. Now let's look at H. Not H, sorry, B. B is 1/3. So because B is 1/3, this is going to decay. So we're going to use option J. Now let's look at your exponent. You see how it has a +5 in the exponent? That means H is the opposite. It's a -5, which is going to move it 5 to the left, so E. And K is +5, which is going to move it up 5, which is D. All right, let's look at the next one. A is -1, B is +2, H is +5. Take about 30 seconds and figure out what three letters are we going to match with that one. When A is negative, pick the letter. When the base is 2, pick your letter. When H is +5, pick your letter. So there's 3 letters or 3 options that go with this equation. So it's going to reflect. Who picked C? Whenever A is negative, does everyone see how A is negative? That means it's going to reflect, so C. When the base is 2, it's going to grow. And what about when H is 5? What is that going to make it do? Go left 5 or right 5? Right 5. So CHA. Who has CHA? I need y'all to give me a little bit of participation here. Let's do our next one here. All right, so A is 1/4. The B value is 4. And then, Sean, what would you say H is? Positive 5 or negative 5? Negative 5. All right, let's look for your 3 letters. When A is 1/4, Diana, what would you say when A is 1/4? Does it stretch or compress? Compress. So what letter is that? G, yep. B is 4, which is going to make the graph grow. And Xavier, when H is negative 5, what does that make it do? Go left 5 or right 5? Left, so E. So G, H, E. All right, let's look at our next one. 2 more. A, and this one is negative 0.3. The base is 2. H is 0, and K is negative 5. So because H is 0, that's not going to change it. Now, because this is a negative, it's going to make it reflect. So I'm going to choose option C. But it's also 0.3, which is going to make it compress. So compress is option G. The base is 2, which is going to make it grow. It doesn't go left or right. So, Gabe, because K is negative 5, what is that going to make it do? So, because K is negative, K moves it up and down. So, it's going to move it down 5. Good. Good job. All right, last one, and then we'll start graphing. So, we have A is 1/4. B is 2/5. H is 0. K is 5. So A is 1/4. That's going to make it compress. So G. The base is 2/5, which is going to make this graph decay. So J. H is 0, so it doesn't go left or right. K is positive 5. So Babacar, what does that do when K is positive 5? Go up. And that would be your answer choices. Any questions? All right, so let's get to graphing. So we're going to skip over the next one. Let's go to the next page and go to example 4. Oh, before we do that, page 4. This is important about an exponential graph. So an exponential graph, this is the first time we are introducing this word asymptote. So exponentials have a horizontal asymptote. And it's like an invisible line that the graph does not cross or touch. And that's always going to happen at y equals k. So for an exponential graph, the k value has a lot of important roles. It controls our range, and it also controls where our horizontal asymptotes are. All right, so let's hit it. So example 4. So let's start off with this. This is called the parent. So let's go ahead and graph that. So we have 2 tables. Our tables look a little different. So I'm going to use this to the one to the left for my parent. And we're going to use the numbers -1 to +3. Now, everybody, look at your yellow calculator. Can everybody look at your yellow calculators real quick? If you don't have one, grab one. Check under your desk, too, because there could be some under a desk. All right, in the first column, do you see the pi key? Everybody look for that pi key. Thumbs up when you find the pi key. Does everybody see it? Now look at the key right under pi. Do you notice how it looks like a little upside down V? That's our exponent key. So what we're trying to do is figure out our y values, and don't write this down. But we need to figure out what is 2 to the power of -1 and 2 to the power of 0, 2 to the first, 2 to the second, and 2 to the third. That's an exponential. Exponential means we're changing our exponents. All right, so Daniela, pick up your calculator, type in a 2, hit that button, and then hit -1. What is 2 to the power of -1? You should get a fraction normally. What did you get? What did you get? 1 over 2, yep. So we're going to write that as a decimal because we usually like decimals better. So that's 0.5. Now pick up your calculator and do the same thing for 0. Type in 2 caret 0. 2 to the power of 0. What do you all get? 1. Anything to the power of 0 is 1. So that's my y value when x is 0. Now do the same thing for 1. So Jaden, type in 2, hit the caret key, and 1. Tell me what you get. 2 caret key 1. What you get? 2. All right, 2 squared. That means 2 times 2. What's 2 times 2? 2 caret key 2. What do you get? 4. And then last one, 2 caret key 3. What do you all get? 8. All right, let's go ahead and graph it. But before we do that, let's answer these questions. Everything that you see highlighted in green, these all go with the parent. The domain of every exponential function is all real numbers. I'm going to abbreviate that ARN. Now let's look at your table. Because when you look at your table, do you see how your x values are positive and negative? That's how I know it's all real numbers. But over here, do you see any negative numbers? Did we get any negative numbers when we tried to get our y values? Were any of these numbers negative? They were all positive. So that tells me my range is y, and it's going to be greater than 0. Don't put an equal line because it will never equal 0. It's always going to be greater than 0. And the parent function has a horizontal asymptote at y equals 0. All right, so let's go ahead and graph these numbers off to the side here. And I'll zoom back out in a second. So I don't worry about the -1.5. I'm going to start my graph at 0, 1, 1, 2, 2 up 4, and 3 up 8. And because there's an asymptote, this is what's really, really, really important. Everybody look at the screen for a second. Your graph is not going to do that. All right, it is not going to go under the x-axis because the x-axis is where my asymptote is. What the graph is going to do is going to go straight. It's going to look like it's sitting on top of the x-axis. So make sure that you draw a tail that is straight. It has a straight tail. It looks like a backwards J. That is your parent function. So now that we have our parent, we're going to do some transformations, just like we did on our test yesterday. So this is my parent, this is my transformation. So the A value, A is 3, which is going to make this graph stretch. The H value is in the exponent and you flip the sign. So instead of it being +2, what is it? Instead of +2, what would it be? -2, which is going to make the graph do what? Go left 2. Morgan, what's our K value? And what's that going to make our graph do? Perfect. All right, we don't have a whole lot of space, but we're still going to do the same thing. I want you to take your H value, which is -2, and I want you to add it all the way down to all those numbers. And then you're going to take your Y value, multiply them by 3, and subtract 5 all the way down. So I want everybody to do that, and we're going to create a new table. We're going to put our new values on our second table. So take a minute. So let's start off with this side. Add -2 to all 5 of these numbers. So you have -2 plus 1 and -2 plus 0 and -2 plus 1 all the way down. All right, who agrees with my new 5 x values? Who have that for their x values? Now let's go to the Y column. Take these 5 numbers, multiply them by 3 because that's A, and then subtract 5 and get these 5 numbers. So take these 5 numbers, multiply by 3, and subtract 5. Okay, and I'm not using a calculator, so you might want to make sure that you agree with those numbers. Don't write them down unless they look right. Let me do them again in my head real quick though. Okay, I think they're right. Got them. So before we graph our second function, let's go ahead and answer a couple questions. So first thing first, let me zoom back out. So that graph is these 3 questions are answering about my transformation. So the transformation has the same domain and range. Oh, sorry, has the same domain, not the same range. The domain is all real numbers. So let's go ahead and write that here. And we have a horizontal asymptote. Remember when we started it, I said K is the most important player because K controls your asymptote and your range. So I want you to draw a dashed line at -5. I'm going to draw, this is the invisible line. That's why it's dashed, because it's not a part of the graph. But at -5, I want you to just draw a dashed horizontal line. Because that's the line that this graph is not going to. It's going to sit on top of this line. So the tail is going to sit on top of this asymptote. Yeah. So our horizontal asymptote is going to be at y equals -5. And now let's go ahead and graph. I want you to graph these points. I'm going to graph them over here. So we have a point at, I always just focus on the whole number. So -2, -2. At -1, we're going to go up 1. At 0, we're at 7. And 1, we're at 19. So it's going to come down. And then it's going to the tail is just going to sit right there, right on top of that horizontal asymptote we drew in. And that's what our graph is going to look like. So because of where we put our asymptote, our range is going to become, instead of y is greater than 0, is y greater than, and it's -5. Any questions about this? And this is what we're doing for this whole chapter. All right, let's do one more and then we will end there for today. So the first thing we're going to do is answer questions about the parent. I'm going to graph that in green. Oops, wrong thing. Okay. All right, so now I changed it to a base of 3. So let's go ahead. All these information, the information that you see highlighted in green, for a parent, your domain is all real numbers. Your range will be y is greater than 0. Your horizontal asymptote is y equals 0 because the parent has a k value of 0. But now when we make our table, because our base is 3, we can't go that high. We can only go up to 2. So pick up your calculators, type in 3 caret -1, see what you get. 3 caret 0, see what you get. 3 caret 1, see what you get. 3 caret 2. Now again, the first one is going to be a fraction. The second one will always be 1 because it's 0. And then you can fill in the other ones. So pick up your calculator. Again, that caret key is the number, is the button under pi. So you're going to type in 3, hit that button, -1. 3, hit that button, 0. 3, hit that button, 1. And then you're going to graph it. So remember, the tail is going to sit right on top of the x-axis. So 1 up 3, 2 up 9. 3 to the power of 3 is 27, which is why we can't fit it. So we just stop at 2. So go ahead and connect that and then draw your tail. Go straight out. That's your parent. So the A value, what is that number right in front of the base? Let me zoom in. Yeah, you see that little minus sign right there? That means A is -1. And who can tell me when A is -1, what does that do to our graph? Reflect it, flips it, good. The H value is -3, because remember you flip the sign, which is going to make it go left 3. And then our most important player, which is K, that's the MVP. K is -3, which is going to move our graph down 3. So let's fill in our domain. And again, remember, this is our MVP right here because it controls where I draw my floor. So this is going to be at y equals -3. So let's draw in that dashed line at y equals -3. So let's go here. At the -3, I'm just going to draw in my asymptote. That's where your K value is. And now you're going to pick up your calculator. To all of your X values, you're adding -3. And then to all of your Y values, you're multiplying by -1 and subtracting 3. So go ahead and do that. Get your new table. So you're adding -3 to all of your x values. To all of your y values, you're multiplying them by -1, and then you're subtracting 3. All right, who agrees with my table? All right, let's graph it. Now, what we're going to notice is that this time, because A is negative, it's going to be under the asymptote. Not on top of it, but under. So let's go ahead and graph it. So -3, going down to -4, at -2, -6, and at -1, -12. So this time the graph is under the asymptote because A is negative and it made the graph reflect. So whenever your A is negative and it reflects down, then it's under. It flipped. And that's going to change our range. Normally our range would be y is greater than k. But because A is negative, is y is less than k. All right, so can everybody pull out homework 1 real quick? Couple of announcements about this first homework of chapter 5. First thing first, can you write that it's due on Monday? So this homework is due Monday, February 3rd. And I want you to, for today, just to make sure you're on time with your getting your homework done, because you know there will be an opportunity for extra credit for homework. You should start off by doing numbers 1 through 5. That's what you should be working on now. And number 10, because number 10 is factoring. Now for questions 1 through 5, though, don't worry about the y-intercept. You can cross that out. For 1 through 5, I need to know domain, range, and horizontal asymptote. All right, go ahead and use this time to start working on homework.